Hi guys, this is Merlin. Today I'm just gonna talk about what I learned today. Um, but the first thing what I learned was actually I was studying about like WebAssembly, and the reason why I have to learn about WebAssembly is because there I'm making some kind of service which is called Runtrick. So that is kind of like um, the it's just this service that helps people to understand how to learn coding thing, but that integrated with the AI thing. Example, chatbot or those kind of AI tutor thing is integrated with our education service. And in our main feature is code execution. So the the user don't have to really install something. They just have to go to our website and they can just edit their code. And if they wanna execute their own code, they can just they can just run as code, and there will be some kind of appears on it. But those kind of code execution is basically it's really hard to make it. So there should be like virtual machine on it. But if there's not, we don't have a really kind of like virtual machine per user. So we use the WASM WebAssembly um, for the code execution. So all of the logic is based on the WebAssembly. So if you look at here, the Fibonacci thing. So if I run it, so those kind of thing is already WebAssembly. So it's really instant. You just don't have to wait for the idle time of it. But the question is, I was trying to like make install this kind of WebAssembly code in my Next.js application. I mean, like it was pretty good, but the problem is that first the Webpack and integration. The WebAssembly is not really JavaScript. It's just it's not really like JavaScript language. It's just I don't know how to say it, but I just reading this kind of like research paper, and it's saying that um, wait, hold on. It's just WebAssembly acts like the stack-based virtual machine. More specifically, it's a virtual instruction set architecture. So the awesome to understand those kind of things, you have to understand the assembly. Assembly is just like really low level of the language. There's a called the ISA instruction set architecture. Yep, instruction set architecture. So based on the x86 and ARM, they both have different instruction because they have the different instruction set architecture of it. So example, so WebAssembly seems like same. Since it's not target for the like those kind of like operating system, yes, I think it's just like assembly instruction set architecture, or for the just the web environment, those kind of thing. And most interesting part is that in JavaScript, if you're trying to compile it, you have to transform the into create data structure, which is called abstract syntax tree. And so, but in this part, in this part, it doesn't try to convert into um, abstract syntax tree. So WebAssembly doesn't just convert into the AST. It just turn it into binary format. So it just decodes the source code into directly into binary thing. So I think that's why it is really fast. It's just like assembly, I think, because I believe that you don't have to really make the tree for the assembly language, because there's already the table of the even the single instructions. So, and that was really fascinating thing for me. I thought WebAssembly is just like the assembly code, but for the like web browser or DOM manipulation thing. But that wasn't. So that is like it's just like ISA, but the some kind of like web environment level. So that doesn't mean it is not for the JavaScript. It's not really replacement of the JavaScript. It's just the assembly. So also, so example, you have C or C++ or Rust or whatever, and there's a WASM specific compilers, and it transport into WASM, and WebAssembly virtual machine can ask you in the x86, x64, and ARM. So that's it's kind of abstraction level of the some kind of AR assembly, but also not really assembly thing, but it's just the awesome, like really low level of the C, but also the higher level of the assembly language, the traditional assembly language. So that was really kind of interesting for me. And but the we didn't really install the library of the WASM. We used we just imported CDN for the when user first encountered our website, and we also apply the cache control, and we inject CDN, and we put the next script. So we just put it into script, and when we try to read this script, see, because we are importing from the CDN, the WebAssembly CDN, right? And when we from the read this script, we have to put this into our custom or a custom Python runner. So we just make this into hook, so into React provider. So if you look at this code here, where's the provider page? Yeah. So the code is really bad, but still, I think it's really. So basically, there's a URL, but whatever. So there's a PODO, so WebAssembly URL. We pre-init the module via React hook. So for the optimization, we just pre-init in the module, and also when we put into script, we just inject on the next script that the make it for the differ on it. The reason why we need to make it for the differ is because we don't want to try to mess with it the rendering the page renders, because we have to make sure that this script evaluation has to be after the render. So we make it into async, and after async, after you load it, we put the callback hook to set the PODO, the WebAssembly module, into our custom hook, which is on the use state. So we put use state on the providers so that we don't have to make some kind of props drilling thing. Yeah, so I think this kind of really, like, strategy that we made, because I know there's kind of, if you're trying to use CDN, there's kind of like the issue of it, because we have to rely on the CDN. What if CDN's the module is not really correct, and there's gonna be issue on it? So we have to really care about those kind of stuff. But still, we're really beginning of here. We don't really trying to make some kind of like very great performance into first level, because that's too over engineering. So that's the strategy that we made. So this is it. Have a nice day. See you next time. Bye bye.